So good afternoon, everyone. My name is Rez Mani, and I work for the company Allied Scientific Pro. And the title of today's webinar, NIRvaScan Spectro-Photometer and the newly introduced cloud service. So this webinar is being recorded, and the recording will be sent to you after a few days. So I want to say that this will be different from all the other webinars I've given in the past. I've given this a number of times, always talking about different case studies and modeling and different features of the instrument. But this one will be more focused towards the basically operation, changing scan configuration, the the PC software, the app, how to use different features of PC software and the app, and also we'll be talking about the cloud. So it's some kind of an instruction about how to use the cloud and how different features means. So I would like to ask everyone to feel free to stop me. It's more like an interactive session. So if you want to stop me at any point, feel free to do so. And then we all can also ask questions at any point, about different things. Just to start by giving this is actually the outline. I'll give a little bit of introduction to NIRvaScan, and then I would get into the PC software. So I'll do a screen share and use the PC software to show what are the different features and how you can record a reference or change the parameters. And then I'll talk about uh, the scan configuration, how to change it, and also different scans like column and Hadamard. Actually, Hadamard has only one D here, so sorry about that. I have to correct that. So, and then I'll demo the app. I have some screenshots. Unfortunately, I didn't bring my uh, the Apple iPod Touch because I could actually project it on another computer and show you live, but I did forgot to bring it. So hopefully next time I can do that as well. But I have some screenshots I'll show. Then I'll go into Near Cloud and explain that. So I don't want to go too much into theory here. I'm sure all of you know about the near IR spectroscopy in the range 780 to 2500, and it's used for fast quantitative analysis. And there are all these absorption bonds in food molecules, for example, the CH, OH, NH, and there are all these modes of vibration. So there will be absorption. So you have the fundamental absorption, which is in mid IR, and then in the near IR, you have the first overtone, second overtone, and third overtone. So here is a comparison between the near IR and mid IR, and you can see that the near IR spectrum contains the overtones and combination bands, and is so much more complicated to analyze as compared to the mid IR, which is quite distinct and intense in signal level. So you need to use chemometrics to decipher the meaning of the near IR spectrum and understand what's going on. Here the absorption band diagram. We have the two NIRvaScan instruments that we have are 900 to 1700. So it mostly focuses on the second overtone region. And we also have an extended NIRvaScan that works in 1350 to 2150 in the first overtone region. So a little bit about the DLP technique. It is different. This spectrometer is different from the array detector because in array detector, the diffraction grating sends all the different wavelengths on the array. But in this case, you have a micromirror array and you have a single element detector, not an array detector. So different mirrors will turn towards it one at a time, and they build the spectrum. And that's why there are some fundamental differences between these two uh, techniques, which I'll get to later when I'm describing the scan configuration. This would actually reduce the cost of the instrument because a micromirror array is cheaper than a linear detector array. So you have a low cost, portable, smart spectrometer because of this DLP technology. Here's the schematic of the instrument with the two lamps at 45, 135, diffraction grading, DMD board, single element array. And these are the models that we have. The reflective model, which is used for solids and powders and surfaces, solid surfaces. Then you have the transmission for liquids. It comes with a cuvette. And then you have the fiber unit, which does not have internal lamp. So you have to use an external lamp to provide it with lights and get any signal. So normally it has a 10 nanometer resolution, range 900 to 1700. And then we also have the extended models F11, R11, T11, and these work in the 1350 to 2150 nanometer range. And they are more expensive because the first one, these are about $2,000 roughly US dollars, and these were about 5,000 US dollars. So this would look into the first overtone region. All right. So enough of the introduction. I'm sure you're familiar with it. So let's start with the PC software. And instead of showing this, I will actually show the screen. So this is the actual PC software. So for example, you can see I'm now going to put the reflective model on a piece of paper, and then I press scan. So you can see that it's a scan is progress. And this is the absorbance from a piece of paper. And you can also look at the reference, you could look at the reflectance. So you can see reflectance and absorbance are kind of complementary to each other. So here you have a peak around 1400 to 1600. In the reflectance, you have a valley in the same. So they're complementary. And this intensity, what does this intensity mean? This is the reflected intensity. So you have the reference intensity and you have the reflected intensity. So the reflectance is just a division of intensity by reference. So if you divide the two by each other, you get this. And then if you take and you call it R, let's say R, then you would basically take log of 1 over r, and that will give you absorbance. Okay, so if you look at it here, I'll show you. So you can see reflected intensity, and then you have reflectance is I over I naught, and absorbance is log of 1 over r. Okay, so far so good. So let's examine different features here on the front page. Okay, so reference. So there is a built-in reference which has been recorded in the device when it was manufactured. This has been done in the factory, so they have recorded the basically the spectrum of the tungsten halogen lamp, and they put it in the device. So if you use the built-in, then you can go ahead and scan, and it uses that as your I naught, and it just measures the reflected intensity, divides by that, and then calculates reflectance and absorbance. But this built-in intensity, in order to understand it, we should go to scan config. Okay, so right now it is column 1. This is the scan configuration. So if you look at here also, it tells you what built-in is using. So let's go over here, and we have several of them, like Hadamard is another one. So if I go there and I set device, you put a set device default config, and then you see this changes to Hadamard. So right now it's using Hadamard. And if I want to go back to column 1, I'll just say click on set device default config. Goes back to column. Okay, so when you're in column, these are the parameters that are being used. Okay, so the column number of sections, one. There are different sections in that micro mirror, so it only uses one of them. And scan type, this is spectral range 900 to 1700. The width, exposure time 0.635, digital resolution 228, and maximum resolution, number of averages 6, and so on. Okay, this is the column. So the question is that if you want to change any of these parameters, you cannot use the same. Reference. You need to record a new reference. And I would strongly suggest that you don't change the width. You don't play with any of the other parameters except for exposure time and number of averages. Okay, exposure time and number of averages. So if you want to use a different number of averages, let's say you don't want to use 6, you want to use 10. Okay, so what you can do is you can basically go to edit, and then you can change that to 10, and then you can save it. Okay, so your column right now is 10, not 6. And then you have to record a new reference. So what you would do is you would go to new, and it is using column 1 with 10 averages, not 6 averages, but 10 averages. So then you would use your Spectrolon surface. I'll show you a picture of the Spectrolon, which I'm holding in my hand right now. Here, this is what I'm holding in my hand. The Spectrolon has high diffuse reflectivity. So you would basically use that, and you would record a new reference. So I'm putting the spectrometer right. So I put this on new first of all, and then I put the spectrometer right on top of this surface, and I would just say uh, reference scan. Oh, sorry, this has to be in intensity. This is the reference scan. Okay, and then for the next one, if I want to measure from the paper again, then I put it on previous. So what previous means, that it uses the previously measured reference. So it says previous reference last set on 2021 12/8 at 14:12, which is right now. Okay, so I can do another measurement. I use a scan, and this is my absorbance. So this absorbance has been uh, measured by using the column 1 with 10 averages, not with 6 averages. Okay, and you can do many other measurements. You could do measurements, and it still uses the same reference that we just recorded, and it says previous reference last set on this date. So it still uses the 10. So if you want to change it back again to 6, you can just go back to built-in, and then it will just use the built-in. So I would go back again and change this to its default value. So edit, and I'll change it to 6, which is column 1. Okay, Hadamard has different parameters. So you can see in Hadamard, uh, Hadamard 1, Hadamard, some of the parameters changes. Just 1 minute. I thought Hadamard had 2 device parameters. Number of sections. I thought it had 2, but maybe I made a column 2 Hadamard. So let's go to the manual and look at something about the Hadamard. So there's a difference between Hadamard and column 1. So we should understand what the difference is between Hadamard and column 1. So if we go to here, column and Hadamard. So it says method. This controls the method of the scan. Two options are offered, column or Hadamard. Column scan selects one wavelength at a time. Hadamard scan creates a set with several wavelengths, multiplexed at a time, and then decodes the individual wavelengths. The Hadamard scan collects much more light and offers greater signal to noise ratio than column scan. So if you want to use Hadamard, if you have issues with low signal level, a material does not reflect enough, and you're concerned about the signal to noise ratio, I would use Hadamard. So you see, when I change the column, things change here to column 1. But you still have to press set device config so that it becomes column 1. So Hadamard has different resolution than column. So this is how we set different. Or another thing you could do, you could create a new scan completely. So you can go ahead new, and then you can go ahead and give a name to it. Say you can say test, and number of scan, let's say 15. Number of sections, I could call it, let's say 2. This stuff about number of sections is all in the manual. And then for each range, you can say do it from 900 to 1700. And then here you can just do it from, say, 1000 to 1300. And change. I wouldn't really want to change any of the other parameters. I would not change the width. I would just play with the exposure time and number of averages. So you could play with these. There are a number of possibilities here for exposure time. The lowest 0.635 and the highest 60.96 milliseconds. And digital resolution, we have to refer to the other ones, see what values they use. I use the same values there, and save. So now you see we have another set that we created here. So test, and then if I do set device default config, it uses that test. So you can either edit an existing uh, scan config, or you can build a new one altogether. So as I emphasize again, I would just recommend that you don't change many of the parameters, because uh, some of these parameters like scan width, digital resolution, start and end wavelength, these are all wavelength and intensity parameters. But so this is very important for the scan. But the exposure time and number of scans to average, there are time parameters. So you can play with these. It would not affect the scan that much. So it's better to keep those other ones the same, and then only change these. And we'll talk about it a little bit later when we go to the app as well. And of course, you have the saved scan here. So once you make measurements, you can decide in which directory you want to save them. Of course, you have to select the directory here, and then if you want to give a particular file name, you have to give your file name here, and run it, and then it will save under that. So once you have your save scan, you can put in overlay, and then compare several of these together. So you can see I can put overlay. These are all the different ones that we recorded. So I just take it out of overlay, and I just do this one. Absorbance. 1 second, please. Overlay. Oh, this one is an extended. How about these ones? If I put under overlay, 1 second. This is one, and this is another one, and this is so you can compare all these scans if you put it on overlay. Okay. So at this point, I want to ask the audience if they have any questions about the PC software, because we're going to move to the app after that. Are there any questions that you want to ask? You can unmute and ask me here.
Yes, I have a question. For how, where can I download this software?
Right.
I can't
Yes.
find it.
Yes. Very good question. Yes. So if I go back to my presentation, the latest version is this. So GUI version 3.76 and Tiva 2.47, and I can send it to you. So I have access to the GitHub, and I can share it with you, so you can download that.
Yes,
Okay.
thank you. Mhm.
Yes. And another feature here, by the way, I forgot to mention, the PC software also has the continuous scan select. So you can, if you want to do back-to-back scans, let's say I want to do 10 scans at, uh, at say 3-second intervals. So I'll set this, and then I would just clear, I would press the scan, and then it would just record 10 scans and it would save it into whatever directory you called it there. And it will give different indices from 1 to 10. So you will have all 10 spectra there
In single files or in one file?
in several files, not
Ah,
in one.
okay.
There are different files. So you can see here, I've tried it before. Here, I did 6 scans. I used the app in this case, but I did 6 scans at 3 seconds interval, and I have 6 files.
Yes,
Okay,
okay.
so there's 6 files, not whatever number that you put there.
Yes, thank you, Res. I have a question for the
Yeah.
continuous scanning. Is it possible to average these 10 scans in the app?
No, the software cannot do it. You have to do it externally on Excel. So
Oh,
you can just go there to the file and select the absorbance values, okay, and then paste it into another Excel, and then you have 6 of them, and then just do average. Are you
okay.
following? Yeah. So
Okay, and
that
what means continuous scanning? Is the lamp the whole time on?
No, it's not the whole time. You can try it with your unit. Just don't put the spectrometer on anything. So you look at the window, and then let's say do six scan at 3 seconds. So you will see that it will come on, does the first, then goes off, and then 3 seconds later it comes on, and again goes off, and again like that 6 times. So it's not all on the time. It's not. It's not
Okay,
necessary. It's only comes on when he wants to do the scan.
so when is it possible to take 100 continuous scans
Yeah,
during one
yeah.
in 60 seconds,
In
for
60
example.
seconds.
Yes,
No, no,
100 or 200 scans in a short time of 1 minute.
no. I don't think so, because I think that I don't recommend to have the scan delay of less than 1 second. I think the minimum scan delay is 1 second, because
Okay.
there are other parameters, that there are other times. There's also calculation of the spectrum. There are some other times that are added to this. Okay, so you don't want to rush it too much. I would actually myself prefer to do 3 seconds. So I would say if you want to do 200, you can do 200 here, no problem, but it will take 600 seconds, so 10 minutes.
Hmm.
Yeah. So like,
Okay.
give it time to record properly, because if you rush it too much, there may be some overlap and may not work properly. You can
Yes,
try. I've never
yes, we
tried to.
try it. We figure it out, but we have a lot of peaks, up and downs
Yeah, I don't want to do it too
on the
fast. I
curve.
will.
No,
Yeah,
we
so
have 6 scans in 3 seconds, and we had a lot of peaks on the curve.
I don't see
Why?
how would it be did you try to do one scan from the same material and those peaks are not there?
Yes, for it's in case we are moving the device while measuring it, the peaks are appear. But if we just do one scan, it's okay. I get a normal scan. Yeah.
But the question is your NIRvaScan touching the material, or
Yeah.
is it not?
Yeah. So we have to be sure that we are on the surface. Yeah.
Yes.
I think that's a problem. Yeah. Mm-hmm.
Well, let's just do a small test here. Let's just do a small test. So I will just do 3 scans, okay, at say 3 second interval, right? And I measure it from the paper, okay? So let me just go here and let's set the directory to NIRvaScan, make a new folder. I'll call it test webinar, okay? So directory, what, hang on, what did I do here? Just a minute. I'll say directory. Uh, why it doesn't move downwards? I see. Okay, this PC. Oh yeah, here. C and res near a scan, and then I said test webinar. Is there a directory called? Okay, we could just put it. Let me just make another one called test webinar. Okay. Yeah, it is in test webinar. Okay. So C. Okay, since CRES test webinar, and then I'm just gonna call it test NIRvaScan. Okay, so I'm gonna do that. So 3 at 3 seconds interval, and then see what we have. So let me put on overlay, and then scan. So this is the first one, second one, and third one. So all three of them are almost similar. So if I go to save scan, so these are the ones that I have, right? So overlap, they're actually identical. All of them are the same. There are no peaks, extra peaks. So I'm
Yes,
not,
Rest, you have got a plain paper, but we are scanning food, for example. There's a very heterogeneous um,
yeah.
surface, so we have a lot of got a lot of peaks. But on this settings, there was also a point to make, for example, 6 average
Yeah.
scans.
So
So is it possible to average when we
no,
have
no, this six.
continuous scans?
No, no, no. This six averages. Sorry, this six averages is not a six of average of the continuous scan. Okay, it's not that. This is like every measurement, it measures 6 times and average it. You see?
Okay.
So for the ones that you generate, the three, so if I go back here, right? So if I go to res and see, and there's got to be a test webinar. Test webinar, yeah. There are 3 files in there. You see that? 3 files. These are the 3 of the continuous scan. So what I have to do is I'll go here, I copy this absorbance, right? So Control C, and then I make a new column and I do Control V. Okay. Then I go to
Mm-hmm.
the second one. I open it, and then I go here. I copy this. Okay. Control C. I go to the first file. I copy it here, right next to it. Okay. And then I would go to the. I'll go to the next one, which is this one, the last one. Okay. And then I'll just Control C. I copy it. Control C. And then I would go to the first file and Control V. Okay, so these are the 3 scans. And then I can average them. So I say average of A1 to C1. Okay, so this is the average. So I'm going to plot in each individual one and the average. So this, and this, and then you go insert and you would go and average it. So here, the average is is yellow, and these other ones are the individual ones. So this is how you average it. This other average has nothing to do with that. This other average is just for each individual scan. It does 6 measurements and average it. And
Okay.
this happens in a very short time interval. So milliseconds. So
Okay. So
is
this
that,
6 average, can we change it for the continuous scan? Not. It's not possible.
no, you can. Absolutely you can change it. But
Okay, we
then
can change it.
you need
Yes.
to go to new. This is what I was saying at the beginning. You have, let's say you want to use 60 instead of 6.
Okay.
Okay. Well, you have to be careful. If this number is too large, then maybe I'm not sure if it's going to conflict with the scan delay. So let's say instead of 6, you want to use 10. Okay. So then
Mm.
you would go to new, and you would do a new reference. You make a new reference measurement with the spectral on surface. Okay. And
Okay.
then you go to
Yeah.
previous, and then you can keep using that. You could use, after you do the reference scan, you can go to
Okay.
previous and keep using that previous scan.
Okay.
So I'm doing a reference. This is the intensity. And now I go to previous. And it tells me here, previous reference scan was done at 1433. So you can keep on using this as long as you are on previous. You use the 10 average. Okay?
Okay.
Because
Mm.
this 10 is only for one measurement, one, not for continuous. Then you have to do them externally, as I showed you. You have to average them externally on Excel. Does it make sense? No? Well, I was just saying that for you, when you do 10 measurements in continuous, you get 10 files, right? Then you would just
Yeah.
have to extract these absorbances and average them on your Excel sheet. Okay? Or you have to write a program that averages there. This one is only for one measurement.
Yes.
So it does every milliseconds, it does 10 times every few milliseconds, it does an measurement and average them. So the one plot that is produced is basically, this one is just average of 10 quick measurements that was done.
Okay.
Okay,
Thank you.
no worries. So this is, I think So far, that is enough. I'm just going to quickly talk about the. I'm going to talk about the app a little bit. Unfortunately, as I said, I couldn't project it. Next time, maybe if I want to give this webinar, I'll project the app on another computer and you could see it live. I didn't bring my iPod Touch today. Sorry about that, I forgot. And so let's go to the app and let's look at the app. So we talk about the PC software and reference, how to use a reference. How we talked about how to change the scan parameters and record a new configuration. Overlay plot. We understood what column and Hadamard scans are. Hadamard collects more light and do more multiplexing, so we'll increase the signal to noise ratio. And the latest version of GUI, which I will send to some of the audience, 3.7.6 and 2.4.7. And now let's go to the app. So app, there is a small video here, so which I run. For those of you who don't know, have not used it, I'm sure there are a few names in the audience. I've noticed that they haven't probably haven't seen this device. So let me run this video. It's a short video. How to use NIR and NIRvaScan spectrometer with the ISC NIR scan app on an Apple device. So this is an iPhone. So I turn on the NIRvaScan. The lights come on here, the green light and the blue light shows there. And then I would tap on the icon and I get to the main screen, which has a big lens in the center. I go to the gear box at the bottom right, and then you see select device to connect. I tap on go, and then you see while I tapped on go, the device appears here. So if I tap on it, I'll go back there, and then I go to the main. So I go and tap on the big lens, and here it says looking for NIR MRR1. So now it's going to download some data, some calibration files, and a few calibration files are downloaded, and then it gives you the message tap button to scan. So once you get the tap button to scan, I'm going to start scan here, and then you'll see the light is coming out of the window. So light, you can see is coming out of the window and the scan is done. And then it says receiving data. So you see intensity data, absorbance, and reflectance. That's about it. Thank you. All right, so this was for the iOS, iPhone basically, and you can also get the same app for the Android. So I have the Android link as well. So I'll send you the Android link on the chat if you want to basically look at my video of how to operate the Android. You can use this link as well. So to look at that. So you connect it via the Bluetooth, and as I showed you in the video, and this is the front screen that you get. Okay, so you can see that there are several modes in here. First of all, here you have your absorbance or intensity reference. You can decide what is it that you want to look at. You can also look at reflectance. I think reflectance is another option that is not shown in here. So we normally operate the app with the normal, in the normal mode. Okay, so uh, this already uses the default scan configuration, which is in this case column 1. So let me explain. If you go back to the PC software, so remember we use the set device configuration, and it shows us over here. So whatever the configuration is that we set, which is shown over here, that will be used for the app. So in this case, it's column 1. If you go back there and if you change it to, for example, Hadamard and press set, and this would show Hadamard. And if you open the app, also this would use Hadamard. Okay, so that is fixed. And then these are all start and end, and these ones I don't recommend you to change, although you can change this, but I don't recommend you to change. The only parameters that you can change if you want would be the average scans and exposure time. uh, Not in this case, not in the normal mode. In the normal mode, I'll just use the same parameters that are there to basically use to do the scan, and it uses the reference scan that is already built into the device. But the question is that what if you want to change some of these parameters? Let's say you want to change your your number of averages or your exposure time. In that case, I recommend you to use the quick set. Okay, and I have verified from the manufacturer that you don't need to record a new reference in the quick set. So because the average scan and exposure time, they are time parameters, the software manipulates it or interpolates it so that you could use the same built-in reference. So if you are, say, in a barn or in some kind of field and you're doing the measurement and you don't have your spectral lawn surface to record a new reference, you can use the quick set, and if you want you could change the scan average number of scans or exposure time. So that's fine, and then you have to press set to basically use these new parameters. If you don't want to change any of the parameters, just use the default ones and be in the normal mode. And you can also see that you could do continuous measurements with the app if you set the time interval and number of repeats. So that's fine as well. And after it finishes everything, it gives you the message, continuous scan completed. There's also another mode, manual, which I don't recommend you to use because it has some options about changing the PGA gain, which I don't think should be changed. So I won't recommend you to use the manual. Just remember that if you want to do the normal scanning, which has 6 averages, whatever that column 1 parameters are, if you click on the column 1, it will tell you all the scan parameters. So use normal for that. If you want to change anything with the app, then you can go to quick set and basically in quick set you can change the exposure time and the number of averages. And once you do, let's say if you do in the continuous scan, you do 6 spectra at 3-second interval, all these would be saved in your iPhone, in your Android or iPhone. So if you have, for example, an Android, you could connect it via data cable to the computer and go to the data mode, and you will see it in this. Like I have a Motorola Android, so it says this, and in the internal shared storage, there is a folder called Documents, and then all these time-stamped Excel sheets are available in this in the phone, which you could transfer to your PC. Okay, so at this point, I want to stop and I want to ask the audience if they have any questions about the app. Anyone? Yeah, but one of the audience was talking, this touches has more peaks. Yeah, it's possible that the moisture will cause more peaks, but these are all the artifacts of the samples that you're testing. So whatever parameters it has, whatever features it has, it shows in the spectrum. Any questions about the app? If not, we'll move on to the cloud service. So I've already explained the app and the PC software. So let's move on to our new cloud service. So the cloud service is called NIRva Cloud, and it's free for all those who purchase the NIRvaScan for a period of 1 year. And you can see I can log out, and there is a register button here, so you can go ahead and register your name and whatever information and start using it. So I would log in here. Sorry. All right. So this is the first page that you will. This is the top page that you would see when you go to the cloud. So on the left side, you have a number of menu items: the spectra, profiles, LDA models, PCA model, PLS model, static model. We don't use that much. These two we don't. Master models, we don't really use it right now. And then for pre-processing, we have SG filters. Okay, so uh, for spectra, you can look at different individual spectra. For example, this is for wheat plot, and this will plot it. So you have a low resolution, you have a high resolution, reverse, reset. So this is for individual spectra. There is possible to put some image in there, but we don't really use that. And then for profiles, we we can have like an Excel sheet with many lines. So all the spectra are in the horizontal rows. So I'll give you an example for NIRvaScan. So res NIRvaScan, and then chemometrics, and let's say this. Yeah, master. So you can see these are all the spectra are in the horizontal. In row 2, row 3, row 4, we have 190, 140 spectra in here. And you can also have another one that has the ingredient. So let me look at this. Uh, just a second, just a second. I want to show you the right file. Yes, so you can see there are 6 spectra in there, 1, 2, 3, 4, 5, 6, and the first column has the protein content in percent. So you can prepare a file like that, and then you could go to the cloud and upload it. So you can just use upload and just choose the file, give it a title, and upload, and it will upload that. So here, for example, I have this file. It has 109 spectra. So it also has all these labels with the protein content is given there. You can get rid of it if you want. Hide label, just see it. And then you can also look at high resolution. This is low resolution. This is high resolution. So these are profiles that you can upload on the cloud. And now, what is the difference between upload and add? This is one thing. So upload is the same as the first thing that you see. So if you go there, if you go to analysis, you will see the upload. This is the same as this upload. They do exactly the same thing. But the question is, uh, what is add? So we have a customer who deals with potatoes, and he makes maybe every day 1,000 scans of potatoes, and then he wants to basically make a profile out of those individual spectra. So he could upload all his spectra, and then he could go there and give it a name for the thing, for the profile, whatever information he wants to give there, and then choose those individual spectra, that he recorded and make a profile out of the spectra that he uploaded. So that is also possible. And that's the difference between add and upload. Now, what are the other things that you can do here? You can make a PLS model, and this is very useful for those of you who want to do quantitative analysis. That's very useful for those who are doing the quantitative analysis. So how to do that, how to make a PLS model. So first of all, you would go to add PLS model. All right. So I'm going to call this test webinar. Test webinar 1 is the name of my PLS model. And ingredients, just leave that. Number of components. You should know for your PLS model how many components you want to use. Let's say 20. We want to do 20. And then we would just select one of these profiles, not from the spectra, but from the profiles. So I would choose wheat kcal 190. This is the one that I want to use. So here it asks me if I want to use the SG filter. So remember that SG filter would do second derivative, and it will also do some smoothing, Savitsky-Golay filter. So if I select that, number of new parameters will come. So it asks me the window length, which I choose to be 23. Okay, and then it would say polynomial order. I can use 3. It's better to use always 3 for polynomial, and derivative is the second derivative. Mode, I would leave it like that, and then I will say save. Okay. So now if you go to the PLS model, you see we have this model, which is test webinar 1. And this is our model. And this is our square is 0.8317. And now we want to apply this to a validation data set. So mind you that the validation data set should also have the same number of Savitsky-Golay. So let's go and choose a validation data set. So instead of this, I will use, let's say, yes, I'll use this one. So I will just want to make a Savitsky-Golay with the 23 out of this one. So I will just do SG filter, add SG filter, and we go to profiles, and I will choose this one. And what are the parameters? So 23. So I'm going to say test webinar valid 1. Okay. So 23 polynomial order should also be the same, and save. Okay, so now we go back to our PLS models, and this is the PLS model that we made. So click on it, and then we want to apply that to a validation set. So we would go to this one, test webinar valid, SG Pro, which means that it's for a profile. It was taken from a profile. So select that and then apply the model to match. And then it will make match the apply the model to this validation set. So it makes predictions also. So you will say this was 17.5 and the prediction is 16.5, and 17.3, 17.1, 17.3, 18.16. The R square is pretty low in this case because I didn't do an exact selection of the Savitsky-Golay and number of components. You can choose whatever value you find suitable for these. And so basically it will make predictions for you, and you can also export this prediction to an Excel file. So you don't have to go one by one and check it. So you can go show in folder and look at the Excel file with all the predicted. So you see the true value, these are the predicted values. They're all given to you on an Excel file. And I should also say that sometimes you may want to apply a PLS model to a set of spectra that you do not have their protein content, for example. So the first column in that Excel file is empty. So you can still do that, and then it will just give you its predictions for those values. All right. So for Savitsky-Golay filter, I will go here and I'll show you that how it looks like uh, if you apply. Let me actually go and select a profile and then do Savitsky-Golay. So I say add, and then I say test webinar 2, and I would select, so 13, we could leave it 13, and polynomial order 3, and I would select one of these, let's say VK Cal, save. Okay, so if I go to the first one, if I go to my profile, you can see this is the one that I used. The actual spectra look like this, but what about the Savitsky-Golay? Savitsky-Golay spectra look like this. So this applies, and you can actually go to the high resolution and look at it. So this applies the second order derivative and polynomial of order 3 to the Savitsky-Golay. You can look at it. The other thing that you can do with the cloud is uh, one thing I have to explain in case of SG filter, there are two suffixes, SG Pro and SG PLS. So if you apply the Savitsky-Golay when you are in the PLS model, remember we went over here and we added in the PLS model, we made some predictions and we said apply SG. If you do it from here, it will be SG PLS. But if you do it from here, then you select from here, it will be SG Pro. So that's the difference between the two. You can look at individually at SG Pros to see what the Savitsky-Golay shape looks like. And then finally, I want to say about the PCA models. So these are PCA models which you can again make from the profiles. So these ones are the ones that we made for plastics. So let's look at it. You just have to click on it. So this is for classification. It has put different, you can say, similar compounds together. These are different types of plastic that have been, separated from each other in different PCA model. If you want to make a PCA model, just go to add, and then you give it a title, number of components, and select what profiles you want to put there, and then press save. We also have LDA models here, and LDA models do a better job in separating different types of material. So if you go to the LDA model, you see how nicely they have been separated. So this is type 1 plastic, this is type 2, this is type 3, type 7, and type 6. And again, if you want to make an LDA model, you have to specify the type and then use add. You can select what profiles you want. So I have talked a lot, and I'm going to, I hope I didn't bore you with all this explanation. I tried to do the best that I can to explain more of the features of the cloud. So at this point, I'm going to ask the audience if they have any questions about the cloud. Please feel free, unmute yourself, and we can go a little bit over time. We have all up to half an hour if you want to stay and talk about this. I'm ready to stay till 3:30 and answer all the questions. So I will open. If you have any questions, please feel free to ask now.
Thus, can we deploy this model in the app too, so that it is possible to do a prediction afterwards?
It is definitely possible. Actually, that's a really good question that you asked, because what we did was recently we did this, and I can send you the YouTube video of that. So we did it for the separation of plastics. Okay, and there's a YouTube video for that that I can send you. Actually, let me find you this YouTube video, and I'll share it with everyone. You could watch it after the webinar. NIRvaScan video. Just a minute. I'll just share this, and then I'll explain that. Uh, plastic plastic sorting YouTube video. Uh, watch. Yes, this is the one. This is the YouTube video. So I will share it with the audience. So in this video, what I show is that I measure with the NIRvaScan. The app has been modified because we can always give you the software development kit, and you could modify the app, or we could develop it for you if you want. We could do that. So they modified the app such that the scans are directly saved on the cloud. Okay, so I did a measurement of the from the of the basically any type of plastic, and then the measurement was sent to the cloud, and the cloud runs the LDA model and sends back what type of plastic it is. So see this. Actually, let's watch this a little bit. Hi, my name is Rez Bani, and I'm from the company Allied Scientific Pro. So today I'm going to demonstrate the NIRvaScan spectrometer and a new app that we have developed that can sort different types of plastics. You see, I've made I've put these plastics here on the table. There are different types of plastics. So I would measure the spectrum, the absorption spectrum with the spectrometer. Then I'll send it to the cloud, and the cloud will send the type of plastic back to the app. And this is what I want to demonstrate. So let's start with the mustard bottle, which is a type 1 plastic, and this is PET. So I will measure it, press the scan, measure the absorption spectrum. Now I say identify this material, and it says this material is plastic type 1. So you can see this is correct. So I'm not going to show this whole video because you could watch it later, but you could see that you could develop an app that would communicate with the cloud. The cloud would run a model and give some answer back. So we have done that for LDA model so far for plastics, but there is no reason why we can't do it for a PLS model. But you need to build a calibration model, and then we can use that to develop this app. What is the right number of components for PLS model? This is from Patabi. It depends. It all depends. So uh, you have to basically look at the uh, RMSE value of your data, or R square, and you have to just experiment a little bit, give it different numbers, and see what values give you the lowest RMSE and the highest R square. We actually wrote a Python code that will go through different iterations of PLS number and SG filter, and it will just give you the optimum value. So you need to test. And 20 is not always too much. It could be anywhere from even 5. I've seen it 7 to 20. It depends on the data. So you have to experiment. Does it make sense what I said? I'm not sure. Was it Silke or Karen who asked the question?
Yes, it's very interesting. I want to try it.
Yes. Do you have a capability of developing the app yourself?
I don't think so.
So, but you also have like some issues with the privacy, right? So you cannot give us your file for you to make, because we need to put the calibration file, to use the calibration file. Uh, our developer should be able to access your calibration file to be able to integrate it in this cloud thing, with the app. So we can talk about that
Okay, I
later.
have to, yeah, I will talk about it with my manager.
Yes, yes. And
Mm-hmm.
this is also another very good point that I should mention to all the audience, that there is privacy for the cloud. So if you want to create a profile, like for example, here I'm going to uploading a profile. You see, there's a privacy tab in here, drop down menu. So if you choose private, then no one else who gets into the cloud, who uses the cloud, could see your data. It's only you can see it. But if you keep it as open, then everyone else could see your data. Any other question?
Yes. Do you have a possibility to see outliers in the calibration?
Well, visually, yes, I would say. So normally, if you have a really bad spectrum, when you plot the spectrum, the profile, you should be able to see it. But we don't have, to answer your question, we don't have a systematic method of identifying outliers. No, we just rely on the visual assessing of the spectrum.
Mm-hmm.
Any other question? Okay. I hope that this was useful to you. I know it was not the normal way we do it. We did it differently today, describing a lot of the features, and I hope that at least it was somehow helpful to you to understand the instrument and use the parameters more carefully, and also use the cloud service. So those of you who already purchased the instrument, you can go ahead and use NIRvaCloud.ai is the name of the cloud service, or the link for the cloud service. I'm just going to copy it in there. So feel free to use it and register and look at some data. And if you have any questions, you can ask me and I will help you out. So thank you very much. If there are no more questions, I wish you a good afternoon and stay safe. Thank you.
Thank you very
Bye.
much. Goodbye.
Thank
Thank
you.
you.
Thank you. Bye bye.
Bye.
Bye.